Lesson 5 examples, logarithms and properties. Three main properties that we need to look for. First one is product property. Log of m times n to the base of b is equal to log m to the base of b plus log n to the base of b. That means if you take the log of a product, then that is same as log of the sum of log of each one in the product, log of m plus log of n, and we need to put the respective bases. Quotient property. Log of a quotient, which is m over n to the base of b, is same as log m minus log n. That means if you divide and take the log, it is actually it becomes a subtraction. And power property, log of m to the power of p to the base of b is same as the p. This p right here goes to the front. That is p times log m to the base of b. When you talk about these, you need to be careful about the m, n, and p and b are positive real numbers, and b can never be equal to 1. b cannot be equal to 1. Okay. So here's an example. Log 8 times 16 to the base of 2 is log 8 plus log 16 to the base of 2. Or log 243 divided by 9 to the base of 3 is same as log 243 minus, because it is a division, log 9 to the base of 3. Or log 2, example of a power property. Log 4 cubed to the base of 2 is the 3. The 3 goes to the front. 3 times log 4 to the base of 2. Few examples using these three properties. You can see the product property, or you can say it is a reverse of the product property. The two logs are added here with the same base. Base is not given, but it is 10. So if it is added here, so you need to multiply. So it'll be log of 6 times 5, which is 30. So the answer is log 30. Number 2, log 3 to the base of 2 minus log 4 to the base of 2. Since both the bases are same, we can apply the second rule, which is the quotient property, the reverse of quotient property. So since it is a subtraction, you need to divide them. 3 and 4 are divided into the base of 3. So the answer is log 3 over 4 to the base of 2. This is actually the reverse of the power property. The number in front, or the fraction in front, should go as an exponent. So it's going to be log 7 to the base of log 7 to the power of 2/3 to the base of 6. And since 7 squared is 49, and 1/3 is going to be right here. 1/3 is nothing but it's a cube root. So we can put the answer is log cube root of 49 to the base of 6. Number 4, the 2 goes over here, which is power, the reverse of the power property. 2 goes over here, 4 goes over there. So this becomes log 5 squared plus log x squared, x to the 4th to the base of 3. Log 5 squared is going to be log 25. Since it's an addition, this is going to be multiplied together. So 5 squared is 25x4, 25x4 multiplied together to the base of 3. And that is going to be the answer. The answer is log 25x to the 4th power to the base of 3. The number in front, again, going to be the exponent of this x. So it will be, you can see that log x to the 5th power to the base of 4 minus the 1/3 goes over here, log y to the power of 1/3 to the base of 4. Since it's a subtraction, this is going to be a division. X to the 5 on the top, y to the power of 1/3 is nothing but cube root of y. That's right here. So they are divided. So answer is log x to the 5th power divided by cube root of y to the base of 4. Number 6, it is 2. But since we have a log without any base, we need to understand all these three logs are to the base of 10. So 2 can be rewritten as log 100. Since log 100 is 2, we can replace 2 by log 100. We don't have to put the base because the base is 10. It is understood. This 1/2 is nothing but it is the power. So since it is an addition, log 3 plus log x is going to be log 3x. Since it is a half in front, that is going to be on the exponent. So log 3x to the power of 1/2 minus log 7. Since it is a plus between these two, you would definitely need to multiply 100 and 3x to the power of half. Since 3x to the power of half is same as radical 3x, we are putting them together. This plus becomes this 100 and radical 3x is multiplied together. Since it's the minus log 7, that 7 goes to the bottom. The final answer is log 100 times radical 3x divided by 7. Base is 10. Now this is actually the opposite of this one. We are basically condensing an expanded logarithm. We are actually expanding a condensed logarithm. So log 27, we need to apply the division, the quotient rule here. So log 27 over 5 to the base of 3 is log 27 minus log 5 to the base of 3. We can go ahead another step and simplify this. If not, that's just fine. 27 is 3 cube, and this is one of the rules that we have seen before. If 3 is an exponent that goes to the front, and you know log 3 to the base of 3 is going to be 1, so the answer is 3 right there. Log 5 to the base of 3 cannot be simplified, so the final answer is 3 minus log 5 to the base of 3. This is a bit complicated because you have so many things in here. You have a cube root, you have a square inside this cube root, everything like that. So first of all, you can just put the cube root as is actually to the power of 1/3. Since it is the power of 1/3, that power of 1/3 goes to the front, which is 1/3 right here, and expand inside. So that is a log 4 plus log x plus log y squared. Now, since it is a squared right here, and you have a cube root right here, it becomes 2/3. So that is why you have a 2/3 in here, and that 2/3 multiplied by log y to the base of 5. And that's it. We don't have to simplify this further. So this final answer is 1/3 log 4 to the base of 5 plus log x to the base of 5 plus 2/3 log y to the base of 5. And again, this is a quotient rule. You need to expand log y minus log of this one right here. So it's basically log y minus log x plus 1 squared to the base of 4. But the 2 goes to the front. That becomes a 2 times log x plus 1 to the base of 4. And that's what we have. The final answer is log y to the base of 4 minus 2 times log x plus 1 to the base of 4. And that's it.